Thanks so much for putting together this forum, and it's really great to be here with all the other folks who are recognizing the need and the ability to electrify fully on existing panels just by doing a little extra work. And so slide credits down here at the bottom to Josie Gaylord, Home Energy Analytics, and 3C-REN, some of the folks who've helped put together some of the slides in here. I want to share some of what we've been learning through consulting studies for San Mateo County that were funded by BayREN. Josie and I did a project to electrify or make electrification plans for 10 homes there, staying on the existing electric panels. And in that process, we learned a lot, and we've been learning a lot after. So, but basically, we've been learning panels have a lot of amperage space, a lot of power capability. A 100-amp panel can deliver 24 kilowatts of power. That's a lot of power. It's like 34 horsepower. And so then there's also lots of ways to fit all the functions we want into our panels. And, what do we want? We don't want amps. We want hot showers and cold beer. We want clean, dry laundry. We want mobility. So ability to get around in our cars, things like that. So those are the things we want. And then we just have to pick the equipment that can convert electricity kind of efficiently, energy efficiently, and power efficiently, so it doesn't overcrowd the panel. And when I say power, I mean the speed of delivering energy. And that's what this 100-amp limit is on a lot of 100-amp panels. It's that they have kind of a power limit. And so that's what we need to figure out, is how do we get all our needs met within the power constraints of the panel? And it turns out there's a lot of good ways to do it. So some appliances recently have become much more efficient at using the power. And we're learning that those contractors who are trying to solve the imaginary problems by upsizing everything are causing real problems, that they kind of transfer those power constraints up onto the power poles and the transformers in the neighborhood. And that can happen if too many people on the block put in oversized EV chargers. And so that's, possibly a real dilemma until we can get to training the workforce to avoid that problem. There's also these split incentives among the fragmented value chain, from the manufacturers on down through the distributors to the contractors and then to the customers. The kind of the incentives and the interests of the parties might not be aligned. For example, if I ask my barber, do I need a haircut? The answer is always yes. If I ask my electrician, do I need to upsize the panel? I'm probably going to get a yes, because it's a lot of work for them to figure out the calculation that shows I don't. And plus, then they don't make the $5,000 they wanted to charge me to upsize it. So we need to be working on that value chain. But people are starting to get it. Anyway, the problem was split incentives. So I've got that kind of showing here. The slides are dense, so I do hope folks will go over them. They will be distributed afterwards. But basically, we've got the problem of, if we're not careful, the contractors are painting the customer into a corner on their panel by oversizing the first one or two projects. And the solution is program design by BayREN and others to help encourage the more efficient solutions instead of staying agnostic about the efficiency of solutions. And then training for contractors about how each of the trades can be good stewards of the panel and leave space for the other trades. Some of the basic things are avoiding resistor strips in heat pumps, which is a kind of a 1950s approach to heat pumps. When they weren't very good devices back then, they had to have a backup toaster element in there, and that sucked a lot of power and occupied too much panel space. And then the other thing is that you can put in stout wire and put in a smaller nameplate heat pump or other machine on the right size breaker for that thing. And then you've left the client with the capability to be future proof, and they can upsize things in the future, or put it, maybe they want to turn over control to the utility, get a bigger device, the utility controls. I know PG&E is really interested in that R&D. So putting in a stout wire and small draw devices that leaves lots of flexibility for the future. And then now it's also nice to see the HVAC contractors are starting to include electrification planning and heat pump water heaters as services they're going to be offering. So, I use the term watt diet, but the longer version is called panel optimization, if you like more syllables. But anyway, it's got various societal benefits. We're going to need it if we're going to do the rapid electrification to preserve the climate, because there are workforce issues here. It's too many hours or months of work to do all the upsizing. We can get the electrification done without the upsizing, and that'll preserve the electricians, the utility line crews, the utility project planners, the utility distribution engineers, preserve their effort for where it's really needed, because there will be some system upsizing needed, even if we kept all our homes on the existing panels. We will be putting more juice across the grid. There will be some constraints that need to be solved by those workforces. We just don't need to send them on a wild goose chase down into every home to upsize the wires there. So our basic choices in doing this is you can either make a plan, and so that's having a plan for the electrification, so you do it right and you're telling the customer about the plan and leaving the plan with the customer. The customer uses the plan as a shield to protect the panel from the different trades that'll come in, and they'll be able to help each of the trades, like the plumber, or the HVAC guy, help them each understand that they have a given budget of watts or amps in the panel. So making a plan's one way, but can you do it without a plan? Yeah, if you just pick all the right equipment. So if all that was available was power efficient equipment, you wouldn't need a plan, because power efficient equipment would tend to all fit. And then the third option is doing it wrong. And that's the one we're trying to avoid. It's where the first one or two trades get in there and soak up all the panel space, and then you don't have room for the other three trades to complete the project. So anyway, the biggest offenders we're seeing is 50 amp car chargers, which give you about 100,000 miles a year of charging. But people aren't driving that far, so they're way too big for what people need. And 50 amp HVAC systems, sometimes people have two of those. So that's also way too big and not comfortable, because a big heat pump can't cycle down to our most of the hours in our Bay Area climate want really mild delivery from the HVAC system. And if you have an oversized HVAC, it can't give that. So it starts cycling, and that's not as comfortable. So anyway, basically, we've got the problem of electric panels are poorly filled if people are going without a plan, and it leads to all those time delays and expense that Abhijit was able to tell us about. We've been learning that panels have a lot of unused capacity. We can figure out designs for 3,000 square foot homes pretty easily on 100 amp panels, just by making good choices or making plans to implement the good choices, and being careful not to let any trade paint you into a corner. And then we need to work on program designs so that they start encouraging and allowing this kind of smooth watt diet design. So encouraging the right type of devices and allowing them. All right, and so Abhijit was able to show one of these. And then the basic components of an electrification plan are, the most vital thing is a recommended equipment list. Given the constraints of the home, what are the models and sizes of equipment that'll work to stay on the panel? You can show them the electric load calculations, and so we've got tools that do that. Because like we said, sometimes the electricians aren't going to bother doing it. They just want to sell the upsize. And then sometimes a wiring plan's helpful. And a wiring plan just has wire sizes, conduit sizes, things like that. But the project list for the contractors to bid on is the other important thing in an electrification plan. So that would have like photos of where the water heater is and what size you're trying to get in there. All right, this graph is kind of nice. It's from HEA, Home Energy Analytics. It's 1,500 homes arrayed across the bottom, 1,500 different homes. And in the blue is what is their the highest annual peak loading they took across their whole electric panel. And hopefully you can see my cursor for the whole year, the prior year. And so the blue line shows how much the peak utilization was for the panel. And it was always at or below the blue area for any home. And then the orange area above is all the unused capability of the panels. And what we can see is very few panels of each panel size. And so here's all the 200 amp panels are these roughly 600 panels across here. And you can see, none of them are fully loaded. The average ones are, quarter loaded. A couple of the 100 amp ones look like they might have gotten fully loaded. And, but, other than that, there's a lot of panel space out there. There's a different way to look at that graph. The blue line is all electric homes, more than 100,000 all electric homes on the graph, I believe. And then the orange line is the blue line was gas homes. And the orange line is all electric homes that have converted over to all electric or were built all electric. And what you see is that the average difference between the gas home and the all electric home is 2 to 4 kilowatts of peak load for the highest hour usage of either of those homes. So it's not adding as much as people imagine. And this is a graph I really like because it takes the 5 end uses like clothes drying, cooking, water heating, space heating or HVAC and cooling, and EV charging, those 5 major electrification end uses. And it shows an array of devices to get those needs met in our house. And then it shows on the bottom, what is the kind of panel loading or transformer watt loading of those devices. So here's 2 kilowatts, 4 kilowatts, 6 kilowatts, up to 10 kilowatts. And so for a combined washer, condensing, or heat pump dryer, they make a combined machine. And I use one, my daughter uses one. It's a device where we put dry, dirty clothes in, and 2 hours later, you get dry, clean clothes out, and you never had to visit it in between. And so that sits on the washing machine circuit, so it doesn't add any additional load. It's on the load that was already there for the washing machine. Okay, but then if you like separate machines, like it'd be almost like if you had a dishwasher and you had 2 machines next to your dishwasher, so you get the wet dishes out of the dishwasher and you put them in the dish dryer. That's how most people do laundry. Okay, but if you are into that, then you could have a separate heat pump dryer or a condensing dryer, or they make a hybrid that's half resistance dryer, half heat pump, if you like your clothes really toasty. And then there's the regular old, clothes toaster, the resistance dryer that uses a lot of watts. And these are how many watts it counts on the panel. The actual amperage or wattage on that resistance dryer is about 4,500 watts out here where my cursor is. But in the panel calculations, because it's not coincident all the time with the building peak, we count it over here. So I've applied these coincidence factors. And then anyway, for cooking, we've got a new 120 volt battery plug-in induction range, really kind of a neat device, using very little power. And then here's a slide-in range, like Abhijit was mentioning. You can have a range that's got an oven and a cooktop. That's really common. Half of all homes have those, and the other half have separate wall ovens that add to the counted load. Here it is for water heating. We've got the new 120 volt plug-in water heaters and the 30 amp, regular standard heat pump water heaters here. So definitely you can save a lot of panel wattage there. And then for space heating, we've got different, these are 2 different lines. They're both 3-ton heat pumps. That describes how thermally powerful they are. It's just the more efficient one here at the top uses less power to deliver the same heat. And then the less efficient one uses more power to deliver that much heat. But I also showed, what if somebody talked you into putting a 5 kilowatt resistor strip onto that too, which the contractors, because of a split incentive problem, sometimes they try to talk you into that because it's not their panel. And they just never want to hear anyone complain that my heat pump wasn't as fast as my old gas rocket furnace. And so then they might try to put that resistor thing in there because it's not their panel. They don't care if they paint you into the corner.
Hey, Tom, we
Yeah.
only have about 3 minutes left.
All right. And then, oh, thanks. And then here you can see just Abhijit was getting at this a little bit, these different sized car chargers, but the typical 50 amp one that the electricians are talking folks into is able to give you 98,000 miles a year. But hey, if you're only driving 20,000 miles a year, you can get by on a 10 amp circuit. All right. And let's see, there's a, we talk about the code, there's a top-down method we can use for showing code compliance from using their history. And I'll just show you that real quick. We look at the history. There's all the hours of the year. Look at the peak load, 4 kilowatts. There's that peak load of 4 kilowatts compared to the 24 kilowatt capacity of a 100 amp panel. So there's a 24 kilowatt green line at the top, 0 kilowatts at the bottom. The panel can do 24 kilowatts. The load was 4. We multiply it by that safety factor that's in the code, 125%. That makes it 5 kilowatts. That leaves 19 kilowatts of leftover space to fit all the new electrification nameplate panels in. And so thanks so much for listening to this. There's a lot of depth in the slides. And so when you get a packet of them, take a look through them and see all the ways to meet your needs.